Hi, Lloyd.
Morning, everyone.
Good afternoon.
Hello, good morning.
Very warm welcome to the video webinar on protection, monitoring, and management of grid assets, which is being organized by Powerline with support of Synaptec. I hope I'm pronouncing it right. Today, what we intend to do is to discuss the following questions and topics. What has been the utility experience in protection and monitoring grid assets? What are the best practices for managing of network assets? What are the most effective strategies for building a more resilient and reliable grid? And what are the latest technologies and solutions for enhancing grid monitoring, protection, and better management of assets? And in this webinar, we will begin with the presentation by technology provider, which happens to be Synaptec, which is sponsoring this particular webinar. And in the panel discussion, we will then have a panel discussion. And then in the panel discussion, we have representatives of Gujarat Energy Transmission Corporation, from Power Grid Corporation, from Transmission Corporation of Andhra Pradesh, and of course, two private players as well, Sterlite Power Transmission and Adani Power, and also representatives of Synaptec as well. I will be, and let me name these people. Dr. Ashok J. Chawla is Superintending Engineer Testing at Gujarat Energy Transmission Company. Welcome, Dr. Chawla. I'm going to introduce you properly later on. Also, we have Mr. Lloyd Claiborne and Nitin Mahajan from Synaptec. They'll be joining the panel. Mr. Rakesh Kumar, Chief General Manager, Power Grid Corporation of India. I've had the pleasure of meeting him earlier as well. I'm doing a virtual conference with him earlier as well. Mr. C.S. Rao, Executive Engineer, Power System Studies, Transmission Corporation of Andhra Pradesh. I've had the pleasure of interacting with him as well earlier. Mr. Amitabh Singhal, Vice President, Power Systems, Sterlite Power Transmission. And great to see you again, sir. And Mr. Udit Trivedi, Vice President of Endorse P&M, Adani Power. Thank you for joining us. And of course, I'll be introducing each one of them separately before the panel discussion. We are, however, going to begin with a technology presentation, which will be made by Saul Matthews, who is Commercial Director of Synaptec. And let me briefly introduce him. Mr. Matthews is Commercial Director, has between 2.5 to 3 decades of experience, and he's worked earlier on, about 2.5 decades or so, before he joined Synaptec, and worked for both startup and established brands in IT, mobile, unified communication, and semiconductor industries in many, many different markets. And he has worked in semiconductor, mass storage, telecom, mobile, and back markets. He's also led mass adoption of technologies such as SSD, Bluetooth, and Skype. And he's now driving new technology adoption with Synaptec, providing distributed sensor systems for power utilities to reduce cost and increase reliability for providers and consumers of electric power. We're going to begin with a presentation by him. And the presentation will be for, I think, about 15 to 20 minutes, and then we will have a panel discussion. Mr. Matthews, I think you have the presentation rights, and we are ready to hear from you. We're not able to hear you very well at all, in fact. We can't hear you, and you're not muted. Oh, you are muted. So if you can unmute yourself. You are muted, so. You're still muted. Anchal, could you guide him as to where the mute? It's normally at the bottom of the bar. It says.
Yes. It's at the bottom of your, yeah.
It says I'm not muted. Can you hear me now?
We can hear you now. Yes, now we can.
I don't know how that happened. I'm very sorry.
That's okay. We are ready for you. Yeah.
Right. Now, having done that, am I still showing my screen because this application is not working very well?
We are seeing the screen. We are seeing there's a left column where we're seeing 3 or 4 slides, and then 2/3 of the screen we're seeing the main slide. So
I'll make it one. There you go. That should work now for you. So apologies for the bad start. So thank you for the introduction. My name's Saul, and as you just heard, Nitin and I representing Synaptec today, along with one of our engineers, Lloyd.
Yeah, Mr. Matthews, so sorry for interrupting you. I think there is a setting that you have to do because I'm seeing the next slide as well. So it's taking away. Anshul, do you know how we do that?
Yes, there should be a display setting which should say, if you'll just go onto your, or there's a, on the bottom of your PowerPoint, there is a view presentation mode. If you could just move to that, I think it should work. Yes, this one.
Is that working okay for you now?
No.
Yes, and here, if you can go to your display settings, on top, there is a bottom down arrow on top, on your top view bar. So if there's a display setting that you would need to switch to, I think you're using maybe two screens, maybe that's why.
I'm going to share a screen instead of a
yes.
setting.
Yeah, I think that would be sharing a screen is better than sharing a file.
There you go.
Yeah,
so
perfect.
That works now for you now.
Yeah.
Yes,
perfect.
great.
Perfect.
Apologies for wasting everyone's time. I will push on with this now. So we wanted to talk to everybody today because we've been developing a new technology here in Europe. And as you already heard, I've spent most of my career in launching new technologies, which are taking standard components and technologies which are used and well understood in other industries like in telecommunications and just applying them newly here in the power industry. And what Synaptec invented about 6 years ago was, we could call it distributed electrical sensing. So we found a way to be able to measure critical parameters like current or voltage completely passively, which reduces the capital cost of instrumentation and also opens up some new opportunities to save operational cost when it comes to improving the visibility and control of complex power systems. We started out in the high voltage space working with transmission operators in Europe, in the UK, also in the Nordic region, and now in Spain.
It is not audible.
Yes, you are, sir. Thank you. Yeah, Mr. Rao, you're audible. Yes. Yeah, but we've muted you now. Yeah, Mr. Matthews, go ahead.
Thank you. So we've spent the last 6 years developing systems that are appropriate for transmission grade applications of protection and metering, but we've also learned that it's quite useful for the automation of condition monitoring and asset management.
Excuse sir, the presentation is not audible, sir.
Hear him. Can somebody call Mr. Rao separately and maybe help him? But Mr. Rao, we are able to hear Mr. Matthews. Are you able to hear me, Mr. Rao?
Your voice is good, sir, but that Matthews presentation is not audible.
Okay, it should be okay now because we are able to hear him. Let's try again. Mr. Matthews, if you can say something that we know.
Of course. So hopefully you can hear me because I believe it's okay and I'm transmitting all right and you can hear. I think that might be a local problem. So I'll keep going unless one of you asks me to stop and reset.
Yeah.
So the idea here is that we invented distributed electrical sensing, and I'll come back to explain what that means, but I'm sure you're familiar with these concepts, everyone in the audience, because that's what we're dealing with in the UK and in Europe. We've got a very old legacy infrastructure in the power systems here, which is being repurposed to accommodate renewable supply and demand. And the adaptation to these new supply and demand scenarios is pretty tricky because the goal, of course, is to safely optimize the capacity and availability of these networks and reduce operational cost because, of course, they're regulated, you can't increase price. And when it comes to renewable generation in particular in the UK, that's driven a lot of change because you've effectively got the whole decarbonisation, decentralization of generation and network, producing power inconsistently at different locations and entering the grid at the extremities coming into the center, and challenging how it was built and how it can remain stable, predictable and competent for everything that must be managed in the system. So we noticed that there was a requirement for simply more sensors generating more data in more areas of the grid, because if you can improve your wheel time wide area control, and you can do it synchronously, and you can get that real-time visibility and decision support. Dispatchers will make better informed decisions, and condition monitoring can be automated to save on engineer costs. Now, that's a very grand statement. It doesn't mean anything until we explain literally how this technology works. So I'm not going to go super in depth on this, but you will see here some familiar looking equipment, a very standard looking CT, a current transducer, and a very standard looking, well, that's a combined voltage transformer and CT built into one column. What you're looking at here is a technology which says we can install an interrogator in a central location, such as a substation, where we've got access to a network and a power supply. And centrally from that box, we can reach out along the optical fiber, which is available in the network, to multiplex in series lots of sensors. Now, what that means is that for every optical fiber that's available leaving that substation and following the circuits along its route, we can install up to 30 different sensors for every 60 kilometers of fiber that's available. Now, serially multiplexing them is what I said. Effectively, that's daisy chaining and saying we can look simultaneously and persistently at 30 different locations along the fiber. And by networking them all together through that fiber, you've got a very efficient system for bringing lots of information centrally to one place to correlate it, timestamp it, and publish it onto your process bus, station bus, or into your digital twin or your SCADA system. But the idea here is that we use industry standard CTs and VTs, any current, any voltage. They look like the ones you already see and use today in your networks, but we've made them passive. The only thing connecting those devices back to the central unit is light traveling through the fiber. Therefore, there is no power supply. There are no copper wires. There are no large civil works and buildings required to house everything. You don't need telecommunications infrastructure or data networks, and you don't need GPS time clocks or synchronization at the remote point. And because we can remove so many of those costs, again, civil works and buildings, power supplies, copper wiring, and data communications, it's a very efficient way to put a lot more sensors out into some very remote or inaccessible locations to see what's going on and provide very accurate information about what's happening at those places. Now, interestingly, we designed this and we have the worldwide patent on passive instrumentation for current and voltage. That can only be done with our technology. But additionally, these sensors are also capable of measuring mechanical parameters. So as well as current and voltage, we can also measure temperature, vibration, strain, and you can combine any of those functions together in these networks, again consuming up to 30 locations per fiber, to reach out very long distances from the substation, distances that were never achieved before with any other conventional technology. And think of that interrogator as like a super merging unit. You have one point where you can bring all this data together and then publish useful information about what's happening on the network. So the kind of things that we're being used for by operators in Europe looks like this. On the top left, we're being used in digital substation trials. So as people are learning how to deploy 61850 and finding that common language for interoperability of all the IEDs and devices that you'll find in the substation, we've been working with Scottish Power, part of Iberdrola, and also with Statnett, who are the transmission operator of Norway, to provide additional instrumentation schemes. In the case of Statnett, for example, we have provided a shadow bus bar protection scheme, independent of the electromechanical standard scheme, where we're able to instrument all of the bays, produce 61850 goose trip signals to operate the circuit breaker, but even with the same system, we were also able to instrument things like transformers and look for problems with vibration and temperature, improving their digital twin accuracy and also generating new condition monitoring data. And the only thing connecting all those bays and all those assets in the switchyard now is optical fiber, not live copper wiring. So there's a significant saving on space, cost of equipment, but also There's a notional improvement in terms of health and safety, use of copper, and probably most importantly, the speed of installation. What sometimes they could take up to 8 weeks to schedule an outage to upgrade their instrumentation hardware for a protection scheme. We managed to install and retrofit this system in only 2 days. So it's a radical reduction of the footprint and cost of equipment that goes around the primary instrumentation devices. The other thing we've done very recently here, I'm based in Scotland, in the extreme north of the UK. We're working with SSE, the transmission operator there, to implement wide area protection schemes. So this is upgrading from distance protection on traditional circuits to a line differential protection scheme or a unit protection scheme where you've got multiple branches created by new grid connections, and those new grid connections typically are new wind farms plugging into the network, and that makes a dramatic difference again to the cost of the system, where you're able to provide superior faulted section identification using unit protection so that you know which branch contains faults, and then you can respond to a fault in a more appropriate and granular and safe manner. So a lot of our work started out with protection applications, but more recently people in offshore wind and also transmission operators and now railway operators have been asking us to apply the technology for condition monitoring. So while there isn't a fault, what we're doing is looking at those systems and looking at, say, renewable generation. We're looking at RTTR, so real-time thermal ratings. We're looking at termination temperature monitoring on cables, which is often a failure point, which is difficult to instrument today cost effectively because of the distances, the lack of space and the lack of power supplies and networks. It's also being used to understand better how power quality and harmonic affects cables. So we're discovering in the UK that a lot of large-scale wind farms have export cable and array cables under the ocean, which are failing prematurely. They should be lasting 25 to 30 years, and they're only lasting 10 to 12 years. And a lot of that is because of the variable load and the electrical stress that they're being subjected to from these generators. And these inverters are causing a lot of problems. And so monitoring electrical stress, sheath current monitoring, looking for signs of overheating, ohmic overheating at the terminations, all of these devices are built into one system to instrument the wind farm and provide earlier warnings of failures of critical equipment. And of course, a failure in offshore wind, you can probably imagine, costs millions and months of outage and campaign costs to replace these cables. Similarly, in wide area monitoring, we're doing a lot of work with transmission operators who want to understand what's happening with their lines in remote locations. So this could be monitoring for ice loading up in mountainous regions where it's very cold and the lines are hanging down too low, and we want to know if it's dangerously low and the vertical ground clearance is not sufficient, or it's about ampacity and it's about dynamic line rating. And so giving a very precise and accurate piece of information that says what's the current, what's the sag, what's going on with the wind and the temperature in the area on a particular span, rather than relying on probabilistic weather forecasts to find out what's going on. And finally, probably one of the most popular applications we've got is cable fault detection, as this graphic suggests, where you have complex circuits which are mixing overhead and underground lines. You simply want to know with confidence if you can auto reclose on overhead faults because they were transient, and to know with confidence that if a fault is underground, you can treat it as permanent and block that auto reclose function. So this technology allows you to reach out very long distances and with no power supplies or comms at the transition points, install sensors to give you that increased flexibility and the ability to distinguish between overhead and underground faults. So that's kind of an overview of what it does. And the idea we wanted to give you today is you've got one platform which is able to combine all these different electrical and mechanical sensor systems. There are more in development. We're looking at wind speed and we're looking at humidity, and we're looking at quite a few other parameters that are possible, where you can put lots of passive sensors out there, you bring them to one place, and then we can publish it up to 14.4 kilohertz. So you're getting, for example, the entire waveform. you don't miss any transients. You can derive synchrophases from it, and it's incredibly efficient wide area system. But basically, it has the ability to deliver benefits in 3 timescales. We operate in milliseconds for protection timescale purposes. Then there's providing real-time control and insights for people in the control room, dispatchers making quick decisions, and finally, benefits that are expressed over years where you're improving asset management. So think of us as a technology that enables multi-zone protection, and that's about fault detection and identification, or high density measurements in one location like a digital substation, because it's about more targeted fault response, response to a fault up to 60 kilometers away in about 1.6 milliseconds with complete accuracy, and of course less equipment to install or replace in these remote locations because you don't need the power supplies or the time synchronization. When it comes to the human timescales, and we're not looking at faults, we're continuously generating this rich data about waveforms, temperatures, and interactions between load and the physical infrastructure. And that's important because it provides real-time monitoring, such as dynamic line rating for overhead lines, real-time thermal rating for cables. And of course, we're generating synchrophases at least, but actually we're going beyond that. Once you go past 10 kilohertz and we're up at 14.5, you'll get a lot more information about harmonics, power quality, power factors, transients, things that traditional PMUs wouldn't see. But most importantly, there is no data. So you eliminate a lot of the networking costs, concerns about variable network latency. You get rid of phasor data concentrators out of your network. And so we can radically reduce the cost of this instrumentation, but give more information about what's happening in these remote points. And then, of course, that leads to the ability to provide earlier warning of failures. So one of the big programs we're doing at the moment is looking at 400 kV underground cable systems, which are powering the capital of Spain, Madrid. And it's not protection, but we're putting sensors on every joint on that underground cable, looking for sheath currents, so leakages of current, losses of power, inefficiencies, and lots of new parameters which will give you an earlier warning of more failure modes than traditional technologies like DTS, distributed temperature sensing, or partial discharge monitoring. And that's very important to them because they need to know when to engage and when to send a crew of engineers to fix a problem. The goal here is to do that based on us noticing something that's wrong rather than running on a calendar basis. So overall, the concept that we wanted to share with you today, which is rather novel and new, but well tested and now running for several years in European transmission, is that you now have access to a distributed, passive and synchronous monitoring platform, which is ideal for allowing these companies like you to cope with the transition towards renewable energy, to cope with wide area monitoring, and to provide a reliable, robust and retrofittable system. Because it's passive, it's very safe and very quick to install these devices to provide additional visibility in difficult locations. And for us, the real purpose of talking to you today is that we want you to be aware that we can dramatically reduce the capital cost of instrumentation of these networks, improve the granularity and the accuracy of real-time monitoring and measurements, and that will help power system operators reduce the cost of adapting to these future supply and demand scenarios. So I hope that makes sense for everyone as an overview. I'll stop myself there and just allow the panel maybe to take over, and we've also got several backup slides here where we can give you some of the case studies and application notes, dollar savings in more details if that's appropriate. But I'll stop there and hand you back to continue the conversation.
Thank you very much, Mr. Matthews. And before we go on to the panel discussion, I should mention this particular topic has generated a great deal of interest. We have over 110 people logged in right now. And also, I should mention that in some cases, there are more people in each conference room. For example, I think AP Transco, there are 8 people there who are listening to this, showing his login. And we have many other people besides the panel. We have other people who are, like, for example, Mr. R.K. Tyagi from Power Grid Corporation. He's executive director. He's listening in. So a number of people have actually logged in today. They're quite interested in this particular topic of yours. So let me introduce the panel, and then I will do things maybe a little bit differently, but let me introduce the panel nonetheless. This is in alphabetic order. So Dr. Ashok J. Chavra is Superintendent Engineer Testing at GETCO, Gujarat Energy Transmission Corporation Limited. Currently responsible for testing and condition monitoring, and his areas of interest include protection and condition monitoring, diagnosis of power transformer faults, and remedies. He's an electrical engineer from Gujarat University, has a master's degree in power systems from RK University, and has a PhD in SFRA from PDPU Gandhinagar. Also happens to have an MBA. Thank you, Dr. Chavra, for joining us. Wonderful that you could. Also with us,
Thank you, sir.
Mr. Lloyd Claiborne, who's application engineer at Synaptec, and he works between Synaptec engineering and commercial teams to develop solutions for specific industry requirements. And he has an MPhil degree, and he worked during his MPhil, he worked closely with Synaptec to analyze the material properties of their sensors. He has a master's degree in physics from University of Leeds, and as I said, an MPhil, which is in electrical engineering from University of Strathclyde. Welcome, Mr. Claiborne. Also with us is Mr. Rakesh Kumar, who is Chief General Manager, Power Grid Corporation of India, has about 3 decades of experience in commissioning and operation and maintenance of transmission system, currently responsible for managing the pan-India transmission assets of Power Grid with focus area of switchgear, protection, and facts. And his main areas of interest are process improvement, data-driven asset management, and reliability-centered maintenance. He has also worked as an international consultant on behalf of Power Grid and worked with Dubai Electricity and Water Authority and Ethiopian Electric Utility as well. And he's an electrical engineer by training. Welcome, Mr. Kumar. Great to have you with us. Also with us is Mr. Nitin Mahajan, Regional Business Development Head from Synaptec, has about 2 decades of experience in the power industry, specializing in transformer and switchgears and substation automation systems. And he's currently responsible for Synaptec's business for power grid operators in India, South Asia region, Gulf countries, and South Asia region as well. Currently, he's based in India, however. Mr. C.S. Rao, Mr. Chava Srinivasa Rao, is Executive Engineer Power System Studies at Transmission Corporation of AP, known as AP Trasco. He has worked on a number of testing and commissioning of not just transmission projects, but also hydel projects. And of course, has been very heavily involved with maintenance of switchgear protection, power transformers, and capacitor banks. He also was involved in construction of 132 kV, 220 kV, and 400 kV lines, 132 kV and 220 kV substations, and O&M of 132 kV and 220 kV stations, and 132, 33, and 220, 132 kV substations. And he's worked on a number of assignments relating to power system studies, transmission system protection, also relaying and testing of equipment, and power system problem analysis and providing solutions. He's an electrical engineer by training, also has an MBA as well. Mr. Rao, it's always a pleasure to have you with us, and we're very happy that you were able to join us. And we also have with us Mr. Amitabh Singhal, who is Vice President of Power Systems, Sterlite Power Transmission Limited. He has more than 30 years of experience in transmission distribution industry. His work experience has been in the areas of T&D products, substation operations and maintenance, asset management, power system studies, substation design, HVDC system design, brownfield renovation, modernization, operate and upgrade projects. In the past, he's worked with GE, with Alstom, Arriva, and BHEL. He's an electrical engineer from IIT, BHU. Welcome, Mr. Singhal. Great to have you with us, sir. And finally, we have this Mr. Trivedi, Uday Trivedi, Vice President, endorsed PNM, Adani Power Limited. And he has got also 3.5 decades of experience, and he's leading a group of experts contributing to thermal transmission and renewable businesses for projects and operating assets of the Adani Group. And in the areas of power system protection, system studies, excited systems, automation, and metering systems. And his initiatives include innovative system integration protection systems, SIPS, HVDC systems, grid stability, comprehensive protection schemes, and he is also credited with effectively blending numerical and communication technologies, power system studies, and test simulations to bring out high reliability and availability of power systems, which is what we are, of course, talking about today. He is a member of BIS and a number of committees of central and regional level, and of course has participated in many international conferences. So as you can say, we have a very, very eminent panel, and the time is about 2:59. So we've got roughly slightly about an hour, maybe we'll go about 5 minutes more or so. The questions that we wanted to address, which I had earlier mentioned today, utility experience in production and monitoring of grid assets, best practices, effective strategies for building a more resilient and reliable grid, and latest technologies and solutions for enhancing grid monitoring, protection, and better management of assets. We do a number of these webinars where we begin with technology presentations, we have a panel discussion, and then we focus on those questions and we have a discussion. I am, however, going to make a slight exception today because I myself was very interested in the technology that was presented today. And I don't say that in sponsored webinars, I should say that. So I'm going to first just give an opportunity to the panelists if they have any questions, because I'm sure they do, or any comments on what they heard from Mr. Matthews. And then we're going to come back to their issues and their experience and everything else. And I'm just going to go backwards a little bit. So I'm going to with Mr. Trivedi first. Mr. Trivedi, any question or comment you have based on what you saw for Mr. Matthews?
So, thank you so much, Mr. Matthews, for a wonderful presentation, very promising technology we are looking forward to. And I'm sure in the relevant, it's going to be very relevant in the existing and the future systems. Now, one question I am a bit concerned with is the availability of the optical voltage transformer. Though we are very well aware about the optical CTs, the optical VTs are actually not yet commercially available, if I'm not wrong, and you can correct me if I'm wrong. And secondly, to what extent the digital twins you can actually, I don't know whether you're involved with digital twins, but there are also other questions I would like to know more about whether you can deal with those technologies, because that's again, very widely used term, but very well understood and practiced. So thank you so much. Thanks for the answer.
Thanks, that's a really good question. We ought to make a distinction here. I'm sure all of you are familiar with optical CTs.
Sorry, can you mute the people, whoever is managing today? Just now, yeah. Go ahead, Mr. Matthews. Sorry about that.
So, of course, you've got a progression here where you've got the traditional electromechanical instrumentation, and then more recently you've seen companies like GE, ABB, Artechi offering optical instrumentation as well. So the concept there, of course, is that they take the conductor and they're wrapping a fiber around the conductor to polarize the light with the sort of Faraday effect physics to look for a very accurate measurement of current. However, there are some significant problems with that technique, and that is not what we're doing. So they do require power, they do require networks, they have a limited range of up to 20 kilometers, and you often require several fibers and a multiplexer at the remote location to digitalize the signal and send it back. What we're doing is slightly different. We're using the availability of optical fiber like it's supposed to be used as a network that says, now this may not always be true, but typically around the world we find that power systems, when you're using towers instead of poles, and it's over about 66 kV, there will be optical fiber available running along the OPGW and the earth wire. And what we're saying is we use the long range, the low loss and the high bandwidth of that optical fiber to put sensors along it and network them in a daisy chain together. The passive sensing technique that we're using is not the same as those optical CTs. They are not effectively optical CTs. What we're offering is a way to take a standard transformer or transducer, any VT, any CT, and then we're attaching a passive sensor to the secondary of that standard device. So you can choose any protection class or any accuracy class or any nominal or full current level, for example. But it's the trick is that we found a way to connect to the secondary output of a standard CT, and the only thing connecting that sensor back to the central location is a color of light. There is no data.
So you don't need the equipment that Mr. Trivedi talked about, right? Okay.
I suppose you are referring to the merging unit.
Yes. So what our merging unit does is it's permanently illuminating that fiber, and we can see up to 30 discrete signals, reflections back along the same fiber. So it's out and back in the same fiber where we can see up to 30 sensors. And then because centrally it's powered and we take a central time source, like a PPS or a PTP time source, then centrally we can publish all of that data all of the time. And because there are no power supplies or data networks, time of flight, well, literally it's working at the speed of light, connecting the sensors to and fro, and then we're publishing once. So you will get very reliable and accurate information, and the passive sensing technique is incredibly robust. We've been testing our sensors for over 140 years with no accuracy loss at all in our accelerated lifetime testing. So that's one important concept. So it's central interrogation and power, and lots of remote sensors that have a very small footprint. So it's not an optical CT or a VT. So I hope that answers your first key question.
And he also asked about digital twins, I guess, which is
Yes.
just simulation. So I'm
Well,
assuming we can.
So yeah, we were actually surprised by this. Statnett in Norway, the transmission operator of Norway, asked us to instrument a substation, which provides one of the big feeders into Oslo, the capital city. Now, we were originally doing a centralized busbar protection scheme, but because we had so many spare sensors in the system, they asked us to instrument the transformer as well. So we're looking at vibration and temperature, for example, and we were putting that data over 61850, which hasn't been done before. And then obviously the process bus and the station bus are looking for current measurements from us, publishing currents all the time. I think it's a 4 kilohertz system, that one. But they're also using the data that we're generating for temperatures and vibrations to improve the accuracy of their digital twin. So we're just generating one digital feed, and then that feed can go to the process bus or to a server or into the cloud where you can store up that data. So that's the idea there.
Okay, thank you. Mr. Singhal, any question or comment you have, sir?
So instead of a question, I mean to Mr. Matthews, it's a question maybe to the panelists, because I see there are a lot of utility representatives. So while a lot of monitoring happens at the substation level, there is still a lot which can be done for the monitoring of transmission lines. And I think some of the solutions which Mr. Matthews talked about has the possibility to do those measurements on the line side as well. So any, I mean, possibility to see such requirements in the specifications of the lines in the coming future. That's just a comment or a question.
Okay. Mr. Rakesh Kumar, do you want to respond to that? Sir, you are muted, I think.
Sensors, current and voltage sensors, which can be attached with the existing instrument transformers, current or voltage transformers. So, what about the accuracy class? Will the device will accuracy class of the device will be limited to the accuracy class of the existing instrument transformer, or can we do a betterment also?
So yes, if we are secondary connecting a sensor to an existing transformer, then we're only as good or as bad as that transformer is, right? If it's a 5P40 transducer, that's the accuracy we'll be able to give you. We prefer to build our own primary attached devices, because then we've got more control of, you know, things like saturation or dynamic range. And then of course, yes, it could be slightly better. But we can do any protection class for current, and we're now attaining 0.2 for metering and 0.3 for our voltage transformers. So yeah, very accurate. I think the one thing you probably would not use us for is perhaps metering within the substation, because if you've already got all the power and all the comms available there in the yard, we're probably not the ideal solution for that. What we're giving you is that accuracy with a lot of range, because you can go further away and see something remote. But yes, we will always be limited in our accuracy by the quality of the primary instrumentation if we're secondary connected.
Okay. Let me now go to Mr. Rao, Mr. C.S. Rao. Mr. Rao, any questions or comments you have based on what you heard, sir?
I think this digital CTs, PTs used in one of the substation in Kerala by GE. I think it is not successful.
Okay. Okay. Mr. Matthews, any comment on that? Are you familiar with GE's?
We've heard some feedback about problems with optical sensors, not just GE, but also from some other manufacturers where they have problem with perfectly installing them. So the number of windings can make a difference to accuracy, and they seem to be particularly vulnerable to weather change. So any environmental factors like electromagnetic interference or significant change from, say, summer to winter temperature conditions can cause problems for them. So yes, we've heard there have been some challenges, and again, they have very limited range. So because we use different physics, we don't suffer from those problems, right? We don't, our sensors are totally immune to temperature change. In fact, we designed our sensors to self-calibrate live for temperature, so they adjust themselves as part of the monitoring algorithm. So we maintain our accuracy in a very different way. Again, no EM interference. So yeah, it's a very different technology, and I know that they have had problems with that system.
Okay, Dr. Chawla, any comments or question you have, sir? Dr. Chawla, if you have to unmute yourself, sir. Yeah, sir, you have to unmute yourself.
Okay.
Yeah, now it's fine.
Yes. Now my voice is clear?
Yes, sir.
Okay. Now, okay. I want to share my experience also. We have also commissioned GE digital CT at our substation. Okay. It's working very well, but after a period of 5 years, the response from GE not received, and at present it is out of service. So we also contact GE for the same, and the reply from the GE is that it is a pilot project and they got sufficient data on that. So our experience is good for GE optical CT, and we also plan to our one total digital substation, Sevalia, is under project, and we commission in after 1 year. So technology wise, good. Some hurdles is there, but I think the solution must be find out. We totally want to move in digital substation, as SCADA experience is our good, and we run very well. Substation SCADA all are running very well, and one of the digital substation also we have commissioned it already, and there is a 2 numbers of 220 kV wave completely digital, and now we are going to commission 100% digital substation also. Now my question to Matthews once like that. Sir, are you want to say anything?
Yes, we are able to hear. Yeah, please ask your question, sir.
Once again, the same question is, the CT is good, but what's about PT? Our question is only for PT, and its accuracy and its reliability of digital PT.
Okay.
Matthew, please.
Yeah.
Thank you for the question. The simple answer is, if you're installing any kind of current or voltage measurement system using our technology, we will use the same primary device that you specify. You know, if you specify a certain accuracy class or a certain kind of insulator, you know, composite materials or porcelain, we can do any of those. We will be as good as any other technology. The difference is the amount of equipment that you then need to bring that signal back to a central point is radically reduced. So this is about clearing up the service yard of the substation. The digital substation trial we first did 5 years ago now with Scottish Power, that's called the Fitness Programme in the UK. That was the UK's first digital substation. The goal was to reduce the size of the service yard by 25% and remove 4 tons of copper wiring. And we can do that because we're networking all of these CTs and VTs only with optical fiber, which is just safer, right, to lay around the yard, and obviously much less expensive these days. So there's no trade-off. You're not losing any accuracy. And when it comes to performance, well, it's a passive device, so there's less active electronics, less things to go wrong, less complexity. And as I said, I cannot promise you that this will last, 50 years, and it already has lasted 50 years because the technology's only been installed for 6 years at its longest. But in our accelerated lifetime tests in the lab, we've driven the sensors through accelerated lifetime testing past 140 years with no accuracy loss, because we can self-calibrate for temperature and we know what the degradation effects are of the passive materials we use for sensing, and that's programmed in.
Okay.
Mr. Matthews, one another question I want to ask Mr. Matthews. Have you any experience? What my question is, for a single protection, CT and PT digital is okay, but in my substation, I want to use this CTPT for bus bar protection. Okay. So there is a multiple summation of CTs is there. So can this digital CT suitable for the bus bar protection?
Yes, and we've done it. So in its simplest form, we're providing like a unit protection scheme or a line differential scheme, and just saying where is the fault. It's faulted section identification using 61850.92 sampled values if you're using that digital protocol. What we did with StatNet, though, we went one stage further, and they asked us to implement a unit protection algorithm in the interrogator box as well, so that we could trip the breaker using 61850 Goose directly. So it becomes like a completely independent or backup or shadow protection scheme. Yeah. So yes, we can, and we have.
Great. Okay. Let's move to the panel now and just address some of the questions that we had brought up earlier. So my first question, and I'm going to begin this time the other way around. I'm going to begin with Dr. Chawla this time. What are some of the things that you have done lately for protection and monitoring of your grid assets? Dr. Chawla, what are some of the things that GETCO has done lately for protection and monitoring of grid assets?
Particularly for protection. Okay. So recently, lesson learned from blackout on all over India, some 2 or 3. So Ramakrishna committee has given the uniform protection philosophy to all over the India. Okay. So we adopt the same protection philosophy to all our GETCO grid, means in 400 kV lines, main 1, main 2, 220 kV main 1, main 2 also. And the setting of reach and time is the same followed by the Ramakrishna committee report. So we have now recently started to use line differential protection whenever our fiber is available. We have started to use line differential protection in 400 kV line and 220 kV line. Okay, now it's made compulsory if my line length is less than 10 kilometer. In 220 and 400 kV, it is compulsory to use line differential protection by using optical fiber. So it is our protection philosophy, particularly for line and for in our bus substation. We are using bus bar protection. Numerical bus bar is it is compulsory. Even though there is a single bus, we also use bus bar protection. So for protection point of view, we utilize such things. Okay.
Okay, Mr. Rakesh Kumar, same question for you, sir. What is Power Grid doing? Some of the new things that they're doing or they've done in area of protection and monitoring of grid assets?
So as you know that our the transmission asset of Power Grid are quite old, and recently what we introduced that we started monitoring and control of all say around 250 number of substations from a centralized location. So all our stations are presently monitored and controlled. All operations, including issuance of permit to work, everything is being controlled from a centralized location. So it gives us a better visibility, and we can deploy experts at the central location, which is not possible to deploy at all, at so many stations. So by having a small number of experts sitting at a centralized location, we have felt that there are a lot of advantages achieved through the centralized control and centralized monitoring and control of all our operations. And lately also, as we have, based on the recommendation of Ramakrishna committee, we replaced all our static protection relays with the numerical relays, having inbuilt disturbance record features. All settings are being done by a committee, expert committee sitting at our corporate center. We monitor review each and every settings which is for all new elements being commissioned. These are the two recent additions what improvement we have done in recent times.
Okay, I'm going to ask the same question to Mr. Rao. Mr. Rao, in AP Transco, what are some of the things that you've done lately for protection and monitoring of grid assets? Some of the new things you're doing last few years.
The same thing, sir. So we are adopting the sittings as per recommendations of Ramakrishna Committee. So we are also using line differential protection for 220 kV feeders for a length of about 10 km. So as far as 400 kV lines are concerned, we are using this line differential protection of 250 km. So in a Vizag area, so there are number of short lines. In all short lines, we are using this line differential protection. So that the communication facility is available. So that the line differential protection is kept on service. When the communication failed, it will act as a simple distance protection, sir.
Okay. Mr. Trivedi, the same question for you, sir. What is Adani done lately, last couple of years?
So considering that we are into the entire energy business, including generation of thermal as well as renewable powers, and we are one of the largest private utility in transmission as well, our objective is to actually start taking care right from the engineering stage. So what we've done is basically right from engineering, FAT, and commissioning, and then O&M, we are actually taking in totality. We have a very holistic approach. We also have very advanced laboratory and process and study tools, which we actually use very optimally to get the required reliability of our assets and our installations. And we use the technologies like disturbance records, very advanced disturbance records and data analytics to bring it. So we are actually, as far as analysis is concerned, we are still in the nascent stage, but our approach is very comprehensive. So we actually try to bring, and one of the major objectives is to see that not only our productions, as far as production is concerned, not only they operate correctly, but we also test in conditions in which it can mal-operate.
Mm-hmm.
So here I would like to mention what Mr. Matthews suggested, the technology which is being offered by him, because subharmonics is a major concern right now. And it can confuse the protections as well. So apart from all the protections actually are designed to detect and filter some of the harmonics, but subharmonics they are actually not immune to. They are blind to subharmonics sometimes. And then there is a possibility of maloperation also. So, and additionally, what we have done is basically use communication technology and SCADA. For an example, we use GOOS very effectively, not only for data monitoring, but even protections, including designing SIPs. And we have designed very comprehensive SIP schemes for our plants as well as our networks to ensure stability against disturbances. So this is how we have done lately.
Okay, Mr. Singhal, for Sterlite Grid's own networks, what are the kind of things that you've done? And I understand that your networks are relatively modern and relatively new compared to others.
Yeah. So, I mean, frankly, I may not be the right person to really speak about what all has been done because I'm slightly away from that activity. However, what I would like to speak is, I mean, in terms of the things which can be done. So I heard the implementation of line differential wherever a fiber is available. So I think a lot of the utilities are going for conversion of earth wire to OPGW. So that probably is something which needs to be done wherever it is left out. And even at 66 kV network level, I think wherever it is possible, maybe it would bring good benefits. Second thing which could be very, very important, and I believe our Sterlite's arm, which owns the assets, is looking into it, is the health monitoring of the equipment in a very deep way. So I think the topic today is asset management.
Also,
so while there's a lot of monitoring which has been conventionally happening on the equipment, but with today's technologies, there is a lot more, I mean, sensors which are available. I think Synaptec talked about some examples. Similarly, equipment specific, there is a lot more deep insight which you can have in online monitoring. And even though, I mean, from a utility perspective, it may appear as if it's expensive upfront, but if you can save one or two, load sheddings or trippings or generation loss or whatever blackout, I think it more than compensates whatever investment has gone into that. And the third thing is, I mean, we did one pilot installation of a dynamic line rating device. So where the weather data as well as the conductor temperature and current measurements were taken, and this has been, I mean, shown to be very useful to release the latent capacity which is available on the transmission line to carry much more power compared to what is allowed by the static design limits. So these are, I mean, some thoughts which are coming to my mind. Yeah, thank you.
All right. Thank you. I think you talked about management. So let me turn to management part now. What are some of the new things that you're doing in asset management? And I think I'm going to begin with Mr. Rao this time. Mr. Rao, what are some of the new things you're doing in asset management? What is AP Transco doing?
Sir, so we are all
Yeah, Mr. Rao, are you able to hear us?
yes, sir. Just 1 minute, sir.
No issues. Shall I ask the same question of somebody else and then I'll come to you? Mr. Trivedi, I can go to you. Yeah, in asset management.
Yeah, so essentially we are starting with the condition monitoring and the sensors, which we referred to in one of the talks. So sensoring is one of the very critical aspects for right from all instrumentations and for all equipments, including not only transmission, but the renewables as well as the generation plant as well. So sensorization is very important. And then you look into, so asset performance monitoring tools, we are actually right now, we are developing. We have reasonably good progress in that area, but we are actually trying to now actually build it to the bigger, in a more predictive analysis also we are going to, we are right now working on it. So that also requires to be done very comprehensively. So as far as asset is concerned, the idea is to have very comprehensive, not only data management, but also of course from the condition monitoring perspective.
Okay. Mr. Rao, are you able to speak now?
Yes, sir. Sir, with GIS, so we are entering all the coordinates,
Okay.
the power line. So in the GIS, we are able to find out so the location. Next, in the during system studies also, we are using that grid map. So for making Lilo of any line or is there any nearest substation, for that while doing this system studies, we are using that.
Okay. Mr. Rakesh Kumar, in asset management, so the new initiatives you have?
Yeah, actually, in Power Grid, as on date, we have around more than 1,000 ICTs transformers and around 1,900 shunt reactors. So this is a very large fleet, and we used to have an expert committee who used to sit every month to assess the health of the transformers and reactors. Based on the condition monitoring test being done and the dissolved gas analysis, etc. But all those manual efforts were very cumbersome as the asset grew bigger and bigger. So we have and there are some products available in the market also about the health indexing. So I mean our core team studied about the prevalent methodologies and research papers. So based on that, we have developed asset health indexing for based on all annual maintenance test results, dissolved gas analysis available from our own laboratory, and age, loading condition, etc. Everything put together, we have made our own this asset health indexing, which is integrated in our SAP. So through that, we are continuously monitoring. We can see on our dashboard that what are the health of the asset health of the transformers and reactors which are in service. So this is one. And recently we have introduced in the traveling wave based fault locators for our important transmission lines. The transmission lines which are 765 kV, which are very important, as well as many interregional lines in which the fault identification and rectification after patrolling, I mean, it used to take more time. So TWFL being a more accurate device, so we have adopted recently, and it is, I mean, almost commissioned all of them, and we are still observing, and so far it is we feel that it's a good experience.
And Mr. Kumar, you're now managing your assets, quite a few of them remotely from your center in Manasa.
Yeah, all substations are being controlled, monitored and controlled from a centralized location, and most of the stations are unmanned now as on date. Only few maintenance crew are stationed there. So I mean, nobody is deployed for the operation.
Okay, right. If I can go to Dr. Chavda now. Dr. Chavda, some of the things that you've done, sir, recently in the asset management area. And I should mention that those of you who don't know, GetCo is certainly one of the more progressive transcos in the country. Yeah, go ahead, sir.
So, sir, for asset management, very good arrangement is done. We have divided in two categories our asset. One is transmission line and second is the substation. Okay. So for substation, we have developed our own TAMS, transmission asset management system. Okay. And it's a very good because my total 2,000 numbers of substations, 6,000 numbers of power transformer, and accordingly CT, PT, LA, ORRs, countless numbers of equipments is in service. So we have developed TAMS in such a manner that in my remote area, any substation, anybody test the CT, okay, and just enter the result in TAMS. So there is a central monitor from corporate office, and from here we have developed logic in TAMS itself. So by entering the results, automatically action required is automatically show the person that which type of action required. Means for particularly if I enter the 10 delta of result of the CT. So my program compare the previous history with all results, and accordingly they suggest that they required after 3-month test, or they required PD test, or they required replacement. Okay, clear cut. And the replacement history I see from the HO, and from the criticality, automatically allotment will be there. So all my condition monitoring test, the logic I have put in my TAMS is that they provide the necessary action immediately to the entry done by the person. And even I got the list from here. Okay. So it is a very good, and for that we have present one paper in Sigre Paris also, and it's a very good paper for TAMS. And who are using these walls. One more thing I want to clarify, if time permit. So what we done, particularly in Delta. Okay. So we have carried out one best solution for the 10 delta is that we have created a logic that it depends not only the value, but it's the time. Not only the value, but it's depend on the time. So how much time, the rate of rise we calculate. And accordingly, the 10 delta results we suggest for replacement, for retesting, or and the same way, particularly transformer is the very costly equipment. So transformer total health monitoring is done automatically, and for OH, for replacement of bushing, DGA rise to test the PD, all are comes out from the TAMS automatically. So in office morning, when they just click and check how much transformer is DGA is going rise and immediate action required. So I just list out and check that, and accordingly they also monitor the transformer. So centralized monitoring and centralized logic required less expert person, and TAMS is very good. Same way for transmission line, all our transmission location are GPS located, and it is Google Earth. We can check our line easily by all click, single click. how many 66 kV line, 220 kV, 400 kV, all are GPS located. And the same also develop program in-house. The beauty is that both program we have developed in-house. Okay. So for necessary modification required as per our condition, we do easily. And same way in condition monitoring, we provide our logic inside these terms. So all information automatically go. So it's running very nice, and we have very good result for it.
Yes. Okay. Thank you. We're now coming to the next part of the webinar, where what I'm going to do is ask people about the issues and concerns they have about, whether it's about protection, monitoring, or asset management, or resilience issue or reliability issues, their biggest challenges as they see them. And then, of course, we'll go one by one. And then the team from Synaptec can respond where they feel they do have something to add to that, or where they can feel that they have a solution. And then after that, I am going to ask the team, as in Nitin, Mahajan, and Lloyd Claiborne later on, based on what they've heard, what would they comment on based on what they've heard. But let's figure out the issues and concerns of people. And I'm going to begin with Mr. Rakesh Kumar this time. Mr. Rakesh Kumar, what are your biggest issues and concerns right now that you're working on, for which you're looking for ideas? Please, go ahead, sir. Mr. Rakesh Kumar, you're muted, sir.
Okay, so one of the important challenge before Power Grid is to monitor and control the transmission lines, which are spread all across the geography. Am I audible now?
Yes, sir, you are.
So this is one of the major concern, and which is very much vulnerable when the natural calamities comes time to time. So this is one area, and a second area is the aging assets. So we have many transmission lines and substations which are aging, which have the age more than 25 years. So normally in our system we consider the useful life of the transmission system, especially substation, as 25 years. Transmission lines 35 years, say more than 30, approximately 35 years. So in substations, a lot of older assets we are retrofitting with the newer ones, but there are challenges in matching. I mean, we are not replacing all of them. So many of the things which are fine and in good condition. So we replace only those parts, those components which are for which spare services, etc., are not available. So especially control protection, power line carrier communication, and some of the equipments also. So these are the major challenge we are facing, for which we want to have innovative solutions.
Okay. Mr. Mahajan, you can play the referee here, and you can decide whether you are responding to it, or Mr. Matthews is responding to it, or Mr. Claiborne is responding to it. Yeah.
We all are not an issue. See, like for transmission line, like we have certain mechanical sensors like sag, vibration, and temperature, wherein like these are the parameters which affects the aging of lines. So that we have passive sensing system up to 60 kilometer. We can go and we can bring all those data correlated, completely synchronized at the substation. At the substation level also, like we can like say do a lot of with high density data sampling. We can like say do some kind of a data science algorithms based on that data, and give a lot of indications like how the system is behaving and which all assets are getting affected to that. So that kind of solutions we can deploy here.
Right. Okay. Yeah, Mr. Kumar, would you like to say anything further on this?
Can you suggest something which can extend the life of the substation assets? Anyway, for the aged asset, we are going for replacement. Can we do something which can help us in extending the life? For it, not for all, but for some of the equipments. Say our instrument transformers, maybe transformers, power transformers, reactors, circuit breakers, etc.
Yes.
Which can help us in identifying. I mean, when we are planning to replace, we replace the complete lot based on the cases of abnormality observed. So some of them may be good. So in these areas we ourselves are working to find out the actual condition assessment. But if there are any better solutions which we can adopt in addition to our own effort.
See, now each power equipment would need a different testing parameters. Like a breaker would have different LA, different CT, PTs, different. So all those gathering all those parameters in one system, like we are anyway, like as Saul told, like we are into devising of different sensors, innovating different sensors which may help into this kind of an analysis. But as of now, like say there are like limited sensors available with us. Well, Lloyd, would you add in this?
Yeah, I feel that we can't directly extend the life of assets, but what we can do is perform condition monitoring and catch things before they fail, which will save money on downtime when you do have to replace them.
Okay. Right. I'm going to go to Mr. Rao now, and again, please mention whatever your biggest issues are. They don't have to relate to Synaptec, because we are also doing this for Powerline editorial, to trying to figure out what the big issues are. So in some cases, Synaptec will have a solution. Some cases they may not have a solution. But I do want to know what your biggest concerns are. Mr. Rao, what are your biggest concerns today? What is it that keeps you sleepless?
Usually we do this tan delta testing on CTs of power transformers in the substations. So actually for the CTs, liability value is 0.7% because number of the CTs are getting around 3%. That's why we revise the setting to 3%. So once it crosses the 3%, we are checking it continuously for 3 months. If it is in the rising trend, simply we are replacing, sir. So as far as PTS are concerned, the bushing value is 0.7%. So in the bushing case, we are not taking any risk because so if it fails, it may catch fire and finally transformer may go to this firing, sir. So as far as lines are concerned, these old lines we are replacing with so the latest conductor like AL59 or ACSS. So something like that, sir. So like that we are doing, sir.
Okay. Mr. Mahajan, any comment you have, or would you pass?
The tan delta as of now, like we are also trying to see how we do address this. Once tan delta is addressed, I think more than 80 to 90% of asset can be monitored sitting at one place. So to be very frank, we do not have that solution as of now.
Okay. Yeah, I think there was a question on that as well about can we monitor tan delta value. Okay, Mr. Matthews wants to comment on the condition monitoring and analytics. Mr. Matthews?
Yeah, a general point here. What we've been learning recently in offshore wind and in railways, but it applies back to transmission, is the idea that if you can monitor 20, 30 or 50 assets which are fundamentally the same, I mean, I mentioned transformers, but it could be voltage limiters, it could be some other critical balance of plant. We realized that what we can do with our systems is to say, okay, let's look at those 50 things, and if one of them shows a different profile, so electrically or physically, mechanically, if one of them looks different and the other 49 all look the same in that sample set, then it makes sense to use our system to automate condition monitoring, because we can simply say, hey, there's this location over here, something is behaving different, all the others are the same, so go and visit that one because something's wrong, not because it's Friday afternoon and that's the time to go and do it. So it's not machine learning and it's not artificial intelligence, it's just saying you can group similar assets together and perform relative analytics on those in real time to look for those clues. And some people are asking us to go a stage further and say, like, looking at capacitive dividers, and have you got a failure in one of the cells that would lead to an overheating, actually an explosive failure, and looking for these little sort of leaks of current that are the forewarning or the predictor of these failures is really important. So I think there's a lot of value in real-time analytics when you can compare a lot of similar assets and just look for exceptions and anomalies. That will give you at least half of the answer to say how much longer is this going to last. And of course, the longer we monitor these things, the more we can start working on prognostics and forecasting, but we haven't done enough of that yet to prove how effective it is.
Let me go to Dr. Chavra. Dr. Chavra, what are the big issues and concerns you have, things that worry you about your network?
Okay, so particularly in condition monitoring, we have done very well. The big issue at present we are facing is, I think other utility has not a 66 kV voltage class system, but we have a 66 kV voltage class system. Okay, so the 66 kV voltage class network generally provided with simply IDMT overcurrent earth fault relay. Okay, now due to industrial development and huge loss demand, particularly in my Ankleshwar and Dahej area, and same way in Morbi area, we have to construct more numbers of substation in a single line. Okay, so particularly in 66 kV protection, we are facing much issue. For example, if there is a fault in one section of my line, my other substation also going in dark, and there is a huge financial loss. Okay, so other industrial substation are in zero power, the fault in other section of the line. So we want to develop one project plan if anybody are ready. So in radial line, we want to cover all this substation and all this my protection relay with optical fiber, and the central unit will decide which section required to switch off. So this is our dream project, and can anybody help in this particularly project? We are ready to develop.
Mr. Mahajan, would you like to say something?
Yes. This, I think this is Dr. Chavda is referring is multi-ended, multi-zone protection kind of things, and then that we done it in one of the utility in Europe. I think Saul is the right person because he has seen this particular thing working, deploying there, working there. Saul?
That's true. So what you're describing, we've already done. So you can treat sections, you can create any size or number of protected sections and get better faulted section identification from a central point and radially go over. I think, for example, one of our systems, if you're thinking about three-phase power, we could create up to 16 protected sections per fiber or per interrogator. So it's a very cost-effective way to do exactly what you're describing. We have actually done it. And to give you a sense of the cost savings with SSE, the transmission operator here in Scotland, so we had a 2-ended circuit that became a 3-ended circuit because they attached a new wind farm to it. And then to figure out if the branch is here or here containing the fault, traditionally they would spend about just over $500,000 on the instrumentation cost. We reduced that cost by about $300,000. So it was more than half of the cost was saved by getting more sensors in more locations, but only networked through the fiber in the OPGW. So yes, that's exactly what we do, and we can help you with that.
Okay, great. If I can now go to same question to Mr. Trivedi. Mr. Trivedi, biggest concerns and issues you have right now?
So one concern is that earthing systems and lightning systems. So earthing system has been taken a backseat. We hardly understand earthing. We only mean earthing is a pit. So the design of the earthing system is actually very critical. That is one concern as far as technical aspect is concerned. Secondly is the technologies, are extraordinary technologies are available, including what Mr. Paul mentioned. The reliability and the adaptability of the technology. One for the people, the skills development is a major concern. So now with more and more complex systems available, the people who are able to manage it to bring the required reliability is not available. And that has been biggest concern, that has been biggest headache, and I'm sure everybody would share my concern. Right. That is another concern. The third is the various generation mix, the transmission, various power electronics including the transmission and the various types of loads available. There is also a lot of asymmetry in the system. So apart from the loss of the inertia in the system, which is a concern by which you use the synchronous condense sensor on, even if the renewables are actually increasing, the mix is basically bringing a lot of impurities, not only impacting the equipments, including our sources, but it also actually creates confusions in the production side. So the technologies and the various mix, how do we actually ensure that we continue to get the required power quality, not only for the steady state region, but even during the fault conditions for the reliable detection is a major concern. One more concern is the regulatory intervention, compliances, and interpretations. So there is also creating a lot of concern apart from other things, and I think we can elaborate in this, but I don't know whether we have the scope to do so. But these are the four major concerns I would like to mention: the technology intervention, the complexities involved with this, skill development, reliability of the systems we use on the primary side as well as the secondary side, and the regulatory intervention, and of course the earthing systems I mentioned.
Okay. So, well, I think maybe part of one of the things you mentioned, perhaps Synaptec people can address. Mr. Mahajan, do you want to take a shot at it, or?
Yeah, like by one, like earthing systems that Mr. Trivedi has just mentioned, like we are addressing the cable earthing, like a very efficient part, and we are giving similar solutions by detecting the sheath currents, which are like getting cross-bounded and those all things. But anyway, like in Indian context, the cable systems in EHV part is quite less, only in the metros. So that is one part. Yeah, adaptation of technology that we really need to see a step ahead, like how do we do that, the capital cost required for it, and eventually what are the benefits that everybody is going to get. Like say the bottom line is not always the what like on the financial part, one should not evaluate that thing. It should be more on a performance level than that of on a quantifying level. Then on the other hand, like say as you rightly said, the various sources of power systems, generation sources, they are getting into a high system inertia and making it too weaken, and that is precisely like all the Europe, North America, those all countries, and there are mandates coming up why harmonics should be monitored, why CPOW comes in picture, continuous point-on wave rather than synchro phases. So all these things, and like that is why, as I told you, like we are getting instrumentally contributing in this system response kind of a rock of power generation, power flow from one region to another region, all those things we are greatly contributing to those kind of response analytics. So yeah, we are like one single equipment can give you a lot of benefits. So that is one thing. And regulations, like we have very hardly any say. Like we have to really see, like we go to next.
We're not expecting you to answer that one.
Yeah.
But that is something for us to keep on finding as to what the issues are.
Yeah, correct.
Issues are. Let me go to Mr. Singhal. Mr. Singhal, you've of course been in your previous job as well, when you were with GE, you were dealing with many of these clients. And so when you look at the sector overall, and you look at the transmission network systems, from a protection standpoint, reliability standpoint, management standpoint, what would you consider, what would you think are the biggest concerns?
So, I mean, if I look at the topic today, asset management and ensuring grid resilience, so the first thing which comes to my mind is, I mean, a strong network planning. So every utility is seeing load growths, variation of the generation and load because of all this intermittency of the RE these days. So a strong network planning exercise which looks at all the scenarios and then plans a network which is resilient, I mean, by design. So that is something which is, I believe, is a must for every utility. And it's not a one-time exercise. It has to be a continuous every year exercise. And you keep on, I mean, looking at your plans and building according to what is happening on the ground. So that is number one. Number two, I mean, something which is very, very relevant is, I mean, all this climate change. So very recently, we have seen some big weather events on both of our coasts. And also the wind zones in the country have been revised as per the Indian standards. So which renders a lot of the existing transmission assets, I mean, liable for failure in case of such weather events. because they have been designed for the fast, wind speed and all that. So there is a strong need to, carry out a survey and look at those assets and see what strengthening can be carried out and what actions can be taken so that the networks, the lines or the substations are available and they do not, end up in a tripping or outage when you actually need that. So that is something which is very, very important.
Mr. Matthews, I'm assuming that
And
your, kind of analysis can help with that, I'm assuming.
I'm not sure I can answer that. Nitin, would you agree? I wouldn't want to comment. I'm not sure.
See here, like only one thing on the resilience part, since passively we are collecting many data and at a very high frequency. So yes, we can contribute into getting more resilient, not only like monitor voltage and current, as Mr. Singhal has rightly said that the wind zones, the climatic situations are varying. You never know what is happening. So the assets which are there in the field remotely hardly being monitored. So if we do it those passively, like vibration, temperature, and all those things, we can get all those data at the remote location. Even if you get some warning, then we can attend and we can do some kind of a corrections rather than waiting for any failure.
Because
but yes,
like temperature and vibration, right?
Temperature, vibration, and also sag, like mechanical elongation. That also we can monitor with a point measurement, like not like that way. So with that, at least mechanically, we can correlate with the electrical parameters and like help in getting more resilient system present.
Right.
So that way we can help in that.
Okay.
Yeah, one more thing. Specifically, just one question to Synaptec. In terms of monitoring of the lines, so let's say related to weather events or environment. So ice loading on the conductor, the detection of fire in the forest or somewhere along the line path, or even vegetation growth and some tree branch coming closer to the conductor. So, is it possible to do that, those kind of measurements through your technology?
Those are the precise discussions which are also going on in our lab with the people, and we are working on it, sir. But it's a long way to go.
Okay.
The theoretical answer is yes, down to the length of one span or an individual line or individual phase conductor. Yes, we can see those things because we can distinguish different, we can characterize and localize those events and correlate the mechanical with the electrical measurements to tell you what's happening in these remote locations. So yes, it's possible. We just need to agree what those signals mean and how you want to interpret them with us.
Okay. Let me come to the last part now. I'm going to go to each one of you, and if there's something that I didn't ask you that you think I should have asked you about, or if there is something else that you feel you want to talk about, please, this is like 1 minute to speak on anything you would like. So Dr. Chavda, I'm going to begin with you, sir. Dr. Chavda?
Okay, sir. Very good and nice discussion is there. And hope that our solution for multiple grid tripping can be find out.
Okay.
And I'm also ready to share my TAMS very good project and run very well. So it is useful for other also, how we can do that.
Yeah, sir, we will invite
Okay,
we'll invite you to write for Powerline, or we can interview you whichever way you'd like. My editorial team will contact you about TAMS. And we can decide. Maybe it can be an interview on the website, or it can be just a write-up by you, sir. Okay.
But it's a very
good, sir. Go ahead, please, Dr. Chavda.
Okay, but yeah. So if time permit and you invite some special program on TAMS, it's required to for others. Okay, thanks, sir.
We'll definitely do that, sir. We have a conference that's coming up on transmission, lines, substations, and towers. I think we'll invite you for that one, for sure. Okay.
Okay. Thank you, sir.
Okay, Mr. Rakesh Kumar.
Yeah, it has been a very nice introduction, and a lot of thoughts were shared from different utilities and suppliers. So I agree with the at the forum that digitization and analytics is the future in the transmission system as well, like any other sector. So digital station, a better use of sensing technology and better analytics is going to help the transmission system, and this is the future which we always look for, and we should try to find the solutions in that direction.
Okay, great. Let me now go to Mr. Rao. Mr. Rao, any comments from you, sir, or anything that we should have discussed, didn't discuss?
Sir, I am a regular reader for this Powerline magazine. So I think better to have some discussion on utilization of this CVTs for metering purpose. So PTs are available at 400 kV level.
Okay, we can do that, sir. We can definitely schedule a separate discussion for that. I should just mention that, you know, Powerline, of course, we are Indian factor. We do a lot of things. We also have a lot of websites abroad and magazines abroad. But Powerline was our first magazine. In fact, we're going to be celebrating 25 years in just another month and a couple of months. So Powerline is close to our heart, and transmission is particularly close to our heart because we also have something called Global Transmission, which does the conferences across the world and does research reports. And so certainly a lot of these topics are topics that we would love to follow up with as well. Sorry for that 30-second commercial plug there, but I felt I needed to do that. Okay. Mr. Trivedi? Did we lose Mr. Trivedi? We sort of lost him there. Can you see if we can get him back? Meanwhile, Mr. Singhal, anything that you wanted to talk and couldn't?
Yeah, so I mean, just to keep on the topic of asset management and resilience. So as one of the purpose of asset management is that the asset serves its life throughout, I mean, whatever 30-35 years, but also the life is maximized by various, I mean, measures if possible. And also these days, a lot of utilities face the challenges of ROW. I mean, getting lands for lines or substations. So, I mean, combining these two things, there are a lot of solutions which are available for, I mean, operating or upgrading of the existing assets, transmission lines, enhancing the power carrying capacities or renewing the, I mean, the health of the assets. So those solutions also, I mean, are very, very relevant for the, I mean, aspect of having a resilient grid, a good asset management, I mean, philosophy or policy by any organization. And that is what I would like to, I mean, conclude.
Okay. So then, words from Mr. Mahajan, you and Mr. Claiborne first, if you have anything to add or say, and then Mr. Matthews can provide some closing thoughts as well.
Yeah, here like only one thing that yes, traditionally Industry 4.0 digitization plan is on the way, but what I feel is like in our system, we have been like on a greener part, like eliminating all the copper cables from the field, and also like getting a lot of data from the field, from the remotest location up to 60 kilometer, which with the existing infrastructure completely synchronized, which would really help all the transmission sector over here to increase the resiliency, reliability, availability of the transmission line. So that would add to their revenue plan, and also like not to get into the penalized situation from the regulatory also. So that there we can help a lot in there.
Okay, before I go to Mr. Claiborne, we have Mr. Trivedi back. Mr. Trivedi, is there anything that you wanted that I didn't ask you that I should have asked you, or anything you wanted to stress?
Oh, sorry, I got dislodged. So anyway, so thanks for calling me back. So I think the concerns which are already mentioned, what we generally do is to, and what we're looking forward is to how to actually bring the technology. How do we actually bridge the gap between the potential of any technology and what is actually available on ground? That is, in short, I would like to mention that. And then we are actually trying to pursue that, bridge that gap, along with our partners in supply as well as on the service providers both. So in some, yeah. Thank you.
Okay. Mr. Claiborne, anything you would like to say, sir? We haven't heard much from you.
No, I think my colleagues have covered everything quite well. And
you're just listening.
Yeah, I'd like to just quickly highlight that we can, although it's not asset monitoring directly, but we can also feed our measurements into dynamic line rating systems. And yeah, that helps in itself to maximize the current that you can put down lines, and it prevents you from having to replace those lines. So it is a way to extend asset life. Thank you.
Okay, Mr. Matthews, you have 60 seconds.
I'll take those. Thank you. Yeah, I think overall our parting comment for all of you here is to say, yes, you need more sensorization, and ideally for a much lower and affordable cost, which we want to help with. But when you've got those sensors, you're going to be drowning in data and trying to get useful, actionable insights and information out of it. So what we want to help with is not only getting more visibility and seeing more locations and giving you more eyeballs or nerve endings, we've also got to make sure that the information that comes back out of the system is actionable and useful, and it has to be practical and relevant and show to save money. So like Lloyd said, if it's dynamic line rating, that's great. If it's looking for early warning of failures, that's great. But it has to guide your dispatchers and your maintenance crews to know where to engage and when, because it's appropriate, and they'll get so many cost efficiencies by understanding how to action the data. That's where we want to help.
Okay, great. Thank you all so very much. It's been a very interesting discussion, and for that we owe gratitude to Dr. Chabra, to Mr. Rakesh Kumar, to Mr. C.S. Rao, to Mr. Amitav Singhal, to Mr. Uday Trivedi, and of course to Mr. Lloyd Claiborne, to Mr. Nitin Mahajan, and to Saul Matthews, of course. Thank you all very, very much. If we publish something, and which we might in the Powerline magazine about this, we'll make sure that we get your quotes before that. And I think we have I don't remember the dates. Anshul, do you know when the conference is? When is the conference on transmission lines and towers and substations? I can't hear you, Anshul.
8th and 9th September.
8th and 9th September. So you will, sorry, 8th and 9th September. So you will hear from us about that. And that's a conference dedicated to transmission lines and towers and substations. And thank you again for joining us today. Thank you.
Thank you so much. Thank you for having us. Thank you so much.
Thank you. Thank you very much.
Thank you. Good day, everyone.